right, guys, let's get it going right away here because we have a lot to do. We got a lot to get over. If you just look right away here, I'm reminding you guys what law of sines and cosines is. That's how serious we're getting here today. All right, that you may need those to finish off some of the problems. Okay, so that's why I'm having you guys work with some people that you're comfortable working and talking with. All right, this is not anything new I have to show you. You guys know the rules now. You know the facts. All right, now I just want to apply it. So take a look at number one. Everyone see what I'm looking for, the length of that chord. All right, chord X. There's some things going on in that diagram which you should be able to apply a factor to about to tell me something right now. Any groups right now can tell me what's going on, anything that's happening in this diagram. Mike, what's one thing that's happening? That chord is being bisected. So I think what Mike's trying to tell us is, hey, you don't need to find the whole chord. Maybe you just find part of it and then double it. That's okay, because we know that chord's getting bisected. Are you okay why it's getting bisected? Because there's a part of a diameter perpendicular to it. Okay, I also have this random 3 segment hanging out there. What's that called? So do you mean any radii I draw will also be a length of 3? That's not really convenient to have it there. Can any groups draw in a radii that might be a little convenient to help me out to find X? You can draw in all the radii you want, but there's a couple in particular that may help me out. Remember, I know this is 2. I got a right angle. That chord's going to get bisected. Can you discuss in your group maybe where else I could put a radii or a radius that would help me out here? Anybody find one? Where else could I put one in here that'll help me out? One that finishes off a right triangle, right? Why not, right? I can make a right triangle, and guess what that radii is? 3. Can you guys find the missing side of that right triangle? And the missing side is going to be half the chord. So I'll let you and your partners work right now. Round X to the nearest 10th. Round X to the nearest 10th. All right, come on, let's get it going because we got a lot to get across here. Okay, you and your group, explain to me how you went about it. Here you go, 20. How do we go about this? Okay, what Pythag look like? All right, I'm going to put in a different variable, but for X, just so we know we're not solving for that whole chord. But go ahead, and that came out to be the square root of 5, and that's half of the chord. So what do you have to do to find the full chord? Multiply it by 2, so 2 times radical 5 into the nearest 10th. What'd you guys have, Lauren? 4.5. Okay, moving on. Questions? We're going to move on. Questions, because they're only going to get tougher now. All right, look at 2. I got a radius. Let's see what I have. I have a radius of 12. I have a chord length I'm trying to find, and that arc measures 120. Okay, anything I can you want to do here? Because you can add in your own stuff. We just added in a radius of 3 over there. If you can add in something, that'll help you. That's the length of the chord we were trying to find. The length of the chord X. Anybody have anything in particular they want to add into the diagram at all? Hugh? All right, here you go. Everybody, hey, everybody. Hugh's going, hey, let's finish a triangle there. Let's make a 12. Okay. Anybody want to tell me something specific about that triangle? It's isosceles. And what do you know about the angles across from the congruent sides? They're also congruent, all right. But do I know any angles in that triangle? I do. This is what I've been talking about, how all these days build and build now. 120 is also the same measure as the central angle. So if I draw this triangle out right now, I have 12, 12, x, 120. Can you find the other two angles? Maybe that'll help me out. You guys said it was isosceles. What are the other two angles? 30 and 30. Here's one reason why I gave you those formulas. Anybody know what law I can use here to find x, the side? Law of sines. Set one up for me here. Give me a side. 12 over. What do you want me to put it over? Sine of 30. Probably want to put what side next? X over the sine of 120. Here we go. Check your modes. You tell me, what are these in? 30. There should be, by the way, until next year, there should be no reason why your calculators are in radian mode. I know we deal with radians, but that doesn't mean to put it into radian mode when you do. Okay, it should just stay in degrees the entire time until sometime next year. And what do we end up getting here? X to the nearest 10th. We're looking at 18. What are we looking at? 20.8. That's what I'm looking at. Questions? Okay, see what you and your group can fill in from here now. Now I got to find the radii length. See what you and your group can fill in right now. Now that you know some things about circles over the last 5 class days, what else could I fill in here? All right, let's get back on track. Some groups. Here we go, a couple groups. What'd you fill in? If the arc's 86, so's its central angle. If an arc is 80, if an arc and its central angle, always the same. What do we know about 86 and the one next to it? Linear pairs are supplementary, so that'll be 94. What is x referring to? That's a radii, right? And in any circle, what do you know about all the radii? Congruent. What type of triangle is that right here? It's isosceles. What about the angles across from the congruent sides? They're also congruent. So what are those angles? 43 degrees. And this kind of resembles the last problem now. What law could I use right now to find x? Okay, help me set it up then. Give me a side, 20. What do you want to put it over? Sine of 94. And then x over sine of 43. Yep. Okay, here we go. What do we end up with here? What do you got for me, 6? 13.7. Yep. All right, anything you want to ask here? Notice we're using some of the facts. The only way I knew that central angle was 86 because I knew the measure of the arc and the central angle were equal. Anything you want to talk about here? Because yes, we're stepping it up again now on questions 4 and 5. All right, I'm not going to answer the first part. I'm going to have you do the first part on your own. And that is find the radius of the circle first. I will help you with the measure of arc AB in a second. But you and your group right now, knowing your circle facts that we went over on Friday, find me the length of a radius. And yes, I know it's not drawn in. So draw it in wherever you feel appropriate right now. Talk it over. How do I find the length of that radius you're drawing in? Okay, here we go. What do you guys, here we go, 7. Where'd you draw your radius in? Okay, fine, I got that. That's the radius. I know you weren't here, Amy, but if I have a part of a diameter that's perpendicular to a chord, you know what's happening to the chord? It's getting bisected, so I got 12 and 12, and then what'd you use to find the radius? So 5 squared plus 12 squared equals, I'm going to put r squared for radius. And what'd you guys find? 13 feet is equal to the radius. No issues. All right, let's get to the tough part now. Everyone focused in. Find the measure of arc AB. What do you guys know? What am I looking for as the measure? It's got to be in degrees. Okay? There are only 2 ways we know how to find the measure of an arc. One way is if we knew the arc length, because remember the arc length formula uses measure of the arc. Do I know the arc length of AB? I know the chord here, but do I know the arc length here? No, I don't. Anybody else remember how to find the measure of an arc if I'm not given the arc length? And here's a hint. I got to go back. Here's a hint. That was 86. So is the measure. Find the what, Will? Find the central angle. You know the central angle. You know the arc length. Okay. What? Sorry, I misspoke there. If you know the central angle, you know the arc measure. Okay. So we're going to find the central angle. Now, it's not drawn in. Anybody tell me what the central angle of this arc AB would be? It would be angle BC, A. Yep. If you guys can find that angle measure, you have the arc measure. Whew, how do I find that angle measure? Yikes. Well, you already found this was 13, right? This was 13. Okay, it is isosceles, you're right. But where are the 30 and the 60 and the... But how do you know it's 30 and 60? That's my question. But how do you know it's 30 and 60? Why about another combination of a bigger and smaller angle? We don't know, right? And Will said it's isosceles, but I still got a problem. I don't know any of the darn angles. That's my problem, is I got this triangle right here where I know 13, 13, 24, and you got to find me that angle. Yeah, we did do something like this in the past. We have. Yeah, it's the law. Well, I can't use law of sines. I got to use what's called the law of cosines. All right? Because I can't use law of sines because I have no angles. So here we go. Let's review law of cosines. That's why I put it on your top, on the top of the page. Anybody remember what side you always start with? Side opposite the angle we're talking about. So side opposite the angle. So here we go. 24 squared equals B and C squared, which are the other two sides. Other two sides. 13 squared plus 13 squared. Again, I'm using the formula that's on the top of your page. Minus 2 times 13 times 13 times the cosine of the angle I'm finding. All right, I'm a little nervous here. I'm not sure what you're typing in your calculators, but 24 squared. 576. 169 plus 169 minus 338. Anybody remember when we did this what you can't do here? You can't combine all three. What are the only two you can combine on the right side up here? 169 and the other 169, which gives me 338 minus 338 cosine x. Again, can't subtract those, and then that would be 0, and then you're still out of luck. But all right, what's your next move then? If you can't combine them, subtract the 338 over. Subtract the 338 over, yep. And let's see, what should I get there? 238? Anybody? 238? 238 equals, what am I left with on the right side? Be careful, watch your mouth. Negative, yes. 338 cosine x, still waiting now. Next move. By negative 338. Will that give me my angle? No, I still have to do one last. I'm not too sure what that. I'm just going to leave it 238 over. I don't know, whatever that decimal is or reduced fraction is. What's that last step to find the angle? Inverse cosine. Yep, inverse cosine of 238 over negative 338. And what are we rounding to? Nearest 10th. $134.8 degrees. Okay. Questions? Find the radius on the next one. Go ahead, find the radius. I don't think we need to do it together. Find the radius on the next one.
No, I don't.
Okay, lead me through how you set it up. Amy, go ahead. Yep. What about down here on the chord AB? Yep. And then what'd your Pythagorean theorem look like? Yep. And what'd you find the length of the radius to the nearest tenth? 6.7 inches. Got it. All right. Everybody good? Okay. Yeah, I'm going to let you take the arc. Okay. Find the measure of the arc. Do you know the arc length? No. Ooh, arc length. Do you know the length of arc AB? No, so you cannot use the formula for arc length. So then what's the only other way to find the arc measure? Find its central angle. So go ahead, find angle ACB. Find angle ACB, and you can use the 6.7. I'm not going to have you use that whole decimal before you round it. So go ahead and use 6.7 when you use it. All right, I got to ask where we are here just so we have enough time to finish the notes here today. Where are we here? 14? $53.2. How's it looking, everybody? 53.2. This is what it should. You do 6.7 squared plus 6.7 squared, move it over, divide by negative. I'm not too sure what this number ended up being. Divide by that negative number. And then second cosine, 53 point, second cosine, and then you should end up with 53.2. All right, here we go. Welcome back. It's been months. Welcome back, everybody. But now we're going to add in some of our circle facts. All right, let's get right after. Prove the triangles are congruent. How many methods do we have? Proving triangles congruent. How many methods? Oh boy, it's been that long. 5 methods. Here we go. What do you got for me? Okay, here we go. Here are my choices. There we go. And remember, HL only in what type of triangle? Right triangle. Okay, here we go. The arcs are congruent. Let's mark them. Arc AC congruent to arc CB. And that's all I'm going to give you. So I've given you no sides or angles. You need to use all the circle facts you have in your power to find sides and angles. So let's have a group start us off. If those arcs are congruent, what else do I have then? You. They're central angles. Name them. Because I can't say angle O. Angle AOC congruent to angle COB. What did you start out with? Congruent arcs. And this is what we wrote down on Friday. Congruent arcs imply congruent central angles. All right, congratulations. You got a pair of congruent central angles. And you don't have to use circle facts. You can use any old stuff too. Anything's fair game. Where else can I go in the triangles? Go ahead. There it is. Got to remember the old reflexive. Can always rely on that, right? When we're in desperation mode, but we're not because we actually needed this. Reflexive. Got it. So you got 2 pieces so far. Heaven? We could. That's also a true fact. AC congruent to CB. All right, because congruent. How'd you know the chords were congruent, Heaven? Because no, there's no fact that says central angles mean chords are congruent. Got to be arcs. So congruent arcs imply congruent chords, but there's a problem. You do have 3 pieces right now, but I can't use it to prove the triangles. Watch. Is that angle in the middle to use side angle side? No, so I'm not. Those triangles are not congruent. 2 of the goof troop back there. What do you want to tell me? I know you're fighting for position. What are the radii in here? AO congruent to OB. Nice job. Here's the reason, because I know we haven't officially written it down. In a circle, all radii are congruent. In a 0? In an O? I know, I'm trying to prove my point or answer your question. You don't put the dot there. What is it? In a 0? In an O? All radii are. And the next question that you do I have to put in a circle? Well, okay, don't put it then. Are all radii congruent? Every single radii? No, only in a single circle. Now we have, now you have your options. Triangle BOC is now congruent to triangle AOC by a couple methods because we have all this information. No. It was just the order that people gave me and I couldn't use. So I could use what here? I could go side, 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 or I do have enough information for side, angle, side. Yep. We okay there? Okay, let's keep it moving. I want to try to get through the next proof if I can. I changed up the proof statement. Don't prove triangles, prove a pair of angles. But still, what do you need to tell me? If I'm going to get those two angles, CFW and CEW congruent, I'm going to have to, still got to do the triangles. Yep, still got to prove the triangles. Let's start there. I got radius OC is perpendicular to chord EF. Got it. So really, there's the given. What's next on your plate? What do you got, Will? Okay, stop right there. Hey, everybody. And I'm glad that we got to this point. In step 2, you cannot say EW is congruent to WF. What did you just tell me, Will? So you need to tell me that OC bisects what up here? What's the chord? EF. The theorem doesn't say the two little pieces are equal. The theorem doesn't say that. The theorem says the chord gets bisected. All right, what was that theorem that we wrote down a couple times on Friday? Diameter. Anybody want to keep going? And you could write the word radius if you wanted to here. Perpendicular to a chord bisects the chord. You cannot tell, you cannot tell me the two little segments are equal based on that theorem. All right, keep it going. You guys are doing a nice job. Let's go. Let's try to, I still don't have sides yet or angles. What's next? Anything, old or new. Let's go, Emma. Now you can tell me they're congruent. Nice job. EW is congruent to WF, not by the circle theorem, Emma, but because, just like you're riding a bike. Never left. Definition of a bisector. Thanks, Emma. Emma got us a pair of sides. Thanks for getting those sides. Cam? Oh, like I said, riding a darn bike. There it is. CWF are right angles. You remember the reason back in the day, Cam? Oh, watch your mouth. You don't have to say bisectors. Perpendicular lines form right angles. And then after you tell me they're right angles, you can tell me they are. Yeah, buddy. Here we go. EWC congruent to CWF. Anybody remember that one? Whew. You missed them. Okay, where's the other side or angle going to come from now? Mr. Old, Mrs. or Mrs. Old Reliable here. Where is the other side or angle going to come from? The side they share. Hi, Hugh. Oh, you were going to, I thought you had a question. WC, congruent to WC. A reflexive. What makes the two triangles congruent now? What's the method? I didn't have to do what, Emma? Why not? But how are you getting the angles congruent? CFW, this angle and that angle. How are we going to get those congruent? That's what I thought. Let the guy teach. Side angle side. Oh, let's finish this. Side angle side, then why are the angles going to be congruent? What are the letters that just roll off your tongue? C, P, C, T, C. Side angle side. C, P, C, T, C. SSTP, Nick. Come on. Come on, we got a Regents in 2 months.